Well, to me, the creation-evolution controversy really kind of boils down, at least from a scientific point of view, to that whole issue of whether the living things around us, and I focus on the living things, having been in life science my whole life, whether they give evidence of the handiwork of a creator, or whether indeed they can be explained strictly in terms of what we know about the natural properties of the world. And of course, I've come to the conclusion that there is overwhelming evidence for a creator. And so I put this talk together called Chance or Design. I do a lot of flying these days. I fly in airplanes that sort of look like this. In fact, if I'm not mistaken, that's me, right back there. You can see in the window. And the other day I was flying in an airplane, I looked out the window and I looked straight down, and it just finally occurred to me, there's not a thing down there but air. And I asked myself, do I really believe in the physical principles that are holding this plane up? I don't know if it's Bernoulli's principle or something like that that holds airplanes up in the air as they fly. And as I looked about inside the plane, happened to be setting where I could see the latrine door. And it occurred to me that the hinge on the latrine door does not fly. In fact, the carpeting doesn't fly, the seats don't fly. Indeed, you might say that an airplane like that consists of about 10 million non-flying parts. And yet, collectively, the plane flies. No part up here is capable of flight, but when you put it all together, at least most of it, in essentially its normal configuration, you might be forgiven a little slip up here or there, although I wouldn't want to fly on the plane. This whole thing will fly. And we call that specified complexity. The system is complex, and it's specified in such a way that it collectively results in flight and hauling passengers. And I believe that our human body shows just such a specified complexity. In fact, living things all around us. Now, many scientists don't agree, and this is a very distinguished scientist. I'm almost embarrassed to say that I would disagree with him. This is Jacques Monod. He won a Nobel Prize, died some years ago. Back in 1971, he wrote a book called Chance and Necessity. And he said that blind chance is behind all of creation. Now, he didn't mean creation as I would use the word, but he said chance alone is at the source of every innovation of all creation in the biosphere. Pure chance, absolutely free but blind, is at the root of the stupendous edifice of evolution. To evolutionists, there can be no ultimate purpose or design in biological systems, no matter how complicated they might be. A few years ago, I visited the Field Museum of Natural History in Chicago, and they had a multi-million-dollar exhibit there on evolution. And as part of this exhibit, they were emphasizing chance and its role in evolution, and they had a little gambling casino in there. This is one of these dice layouts or dice tables, just as you see in a gambling casino, I've been told. And the children coming through, you see there were a lot of children there, were invited to throw the dice on the table and what have you. And as they did that, above them is a sign that says, "Is life just a game of craps?" Think of it. You're taking your young people out for little entertainment, perhaps even some education. You go to one of the world's more distinguished museums, the Field Museum of Natural History, and your children and you get hit by a philosophical blow that's really pretty heavy. I mean, imagine these children are being asked to consider whether their whole existence, whether their minds, their eyes, their bodies, their parents, their brothers and sisters, indeed their very belief in Jesus Christ as Lord, the whole of the writings of Scripture, whether everything is just simply one big game of dice. Everything just the result of chance. Then, of course, after the dice table, you could go over and work on the roulette wheel here, or the one-armed bandit, and turn the crank, and above that it says that over time, tiny mutations add up to big changes. Well, they got one thing right. Tiny mutations can add up to big changes. About 12, 13 years ago, I My wife of 28 years died of a tiny mutation. It was called colorectal cancer. It took her life in a year. She went to be with the Lord. But that was a big change. So indeed, tiny mutations add up to big changes, but I don't think that's probably what they had in mind. Well, the thing that's intriguing is that one of the world's foremost atheists, who wrote a book called The Blind Watchmaker, actually agrees with me on one thing. We don't agree on many things, but we agree on one thing. In his book, in which he said there is no purpose of design in nature, the watchmaker's blind, he did concede that biology, the study of living things, is the study of complicated things that give the appearance of having been designed for a purpose. Think of that. Here's an atheist who right up front says, hey, look, you look at biological systems, you would certainly come to the conclusion that intelligent design was involved here. But he went on to point out that he doesn't believe in such a thing. In fact, he says nature counterfeits design, makes it look designed when it isn't. But notice the burden of proof is on people who see design and then try to deny it. It's not that there is no obvious evidence for design and you have to try to come up with it and create it. No, even the atheist sees it. Now you have to come up with excuses for denying what you see. Now, I had come to the same conclusion that indeed nature does, biological systems, give the appearance of design. Let me just give you a few examples of some of the things that down through the years struck me as having design, and I'll just pick simple examples. I don't know how much simpler you can get than one human hair. I do a whole lecture on one hair. I always tell people, I only talk about one hair, it takes me an hour. If I talked about 2 hairs, it'd take 2 hours. Now, how complicated can a hair be? Oh, very, very complicated. I actually plucked this hair from my scalp several years ago when I could afford that sort of thing. And you'll notice that this hair, it goes down here, I don't know, a couple of city blocks around the corner. It comes over here, that's the end of it, comes to a sharp point. That particular hair had never been cut. If it had been cut, it'd be truncated right here. And as you go down the length of that hair, it looks like shingles on a roof, doesn't it? Scales, we call that the cuticle of the hair. And you can feel that. If you pull the hair out of your head, or pull a hair out here at a length, and you run your fingers back towards the scalp, you'll feel there's kind of a squeaky resistance. But if you go from the scalp out, it's smoother. And that's because going towards the scalp, you're kind of bucking the edge of the scales here. By the way, it's these scales on hair that is the basis for why a wool sweater itches. Now, wasn't that worth a whole trip down here this evening just to learn that? Now, you know, the intriguing thing, if it wasn't for these little scales, I'm not sure mammals would have survived on Earth. They do a number of things. One is they wrap around the hair and they keep the cells inside. And by the way, the whole hair is dead at this point. It was living down in the scalp. It's dead out here. Keeps all of the components inside together. They're kind of like long, like almost broomstick-shaped cells all packed together. And if this cuticle breaks off, those things can split apart. You've got it, split ends. The other thing is this cuticle allows the hair to all sort of face the same direction and be combed out when it gets snarled. You see, if our hair would have been made out of monofilament nylon of the same diameter, and you got that snarled up, you'd never get it unsnarled. Try working with fish line, the diameter of a hair, and get a little snarl. You might as well just get the scissors out. But when one hair turns on another, the scales kind of lock. And that keeps the hair from becoming hopelessly snarled. In fact, there are companies that buy human hair to make human hair wigs. And the hair just is in a sack, it's all mixed up, and they can just card it out and get all the hairs facing the right way before they put it in as a result of this cuticle. But the most important function of that cuticle on the hair is it locks the hair in the follicle. You know, you grab a hold of a hair and you pull. It doesn't want to come out at first. In fact, you can be lifted off the ground by your hair. I had a teacher who used to do that to me all the time. And the reason that hair doesn't come out so easily is this hair fits down inside the hair follicle and it's locked in with a special locking mechanism that is attached to these cuticles here. Let's take a look at that. If you get down inside the follicle, so we'll just kind of go down there and look. This is the inner wall of the follicle. By the way, there's a couple of red blood cells sitting on the top. And this is the locking mechanism, and notice the little steps fit perfectly. So when you try to pull the hair out, It's being held in by the lock. Now, this gets very complicated, but the whole locking mechanism has to move with the hair, and it does so under control so that it can't be pulled out too easily. And when it gets up to the level of near the surface of the skin, you don't want the hair to emerge with this lock wrapped around it like a mailing tube, so there's special enzymes that digest the lock. In fact, your hair is locked in so well that if you pull out a hair, just feel at the end, there's a little knob there, you pull out 2/3 of the follicle with the hair because of this locking mechanism. Now, if we didn't have that, the hair would just come out of the follicle like nothing. It'd be like getting a hold of a hardened piece of toothpaste coming out of a tube of toothpaste and pulling. Wouldn't it just come right out of there? Because it's soft inside the tube. But here it's locked along the wall. When I look at something like this, I begin to understand why the Bible tells us the very hairs of our head are numbered. If you get a hold of this lock and you just kind of peel it away and look what's underneath there, oh my, every little nook and cranny fits perfectly, every little dimple on the edge of the cuticle. It's a perfect lock mechanism. That's just a hair. And we haven't even begun to plumb the complexity there. Now, if you really want to see something complicated, as Bob was telling me, I picked up a feather some years ago walking into the university. I don't know, you ever pick up a feather? What do you do with it? Put it in your pocket? Then what happens? It, goes through the wash or something like that? But I took this feather in and put it in the scanning electron microscope. This is an instrument capable of magnifying in 3 dimensions. You've been looking at the results of that microscope in the hair and now the feather. And this isn't a huge magnification, but in this case it's a chicken feather. And we magnified it, and I looked at this, and it was just so amazing. I thought, I almost have to get out of the room. It was just overwhelming. And why was I so impressed with this, that it was so complicated and so beautiful? Because, you could take something more complicated, like, say, a piece of the brain, and you could put a piece of the brain in this instrument and magnify it to this level, and you know what you'd see? You'd see something that looks like maybe a piece of fudge that thinks. I don't really know how to deal with a piece of fudge that thinks. But when I look at this feather, it occurs to me the reason I'm so impressed is that its complexity is simple enough for me to appreciate that it's complicated. Does that make sense? Something has to be simple enough for us to understand that it's complicated. If it's too complicated, we can't even get started. You see you have a shaft in the middle, there are barbs that come out of the side of this shaft. And when the feather's down in the follicle, these barbs are all up tight against the shaft. There's a hinge here at the base of each barb. And then each of the barbs has little barbs coming off it, sort of like little miniature feathers. There's one, there's another down the line. We call the little barbs barbules. The little barbules crisscross, as you see here, and the ones underneath there have hooks. And the little hooks hook into the barbules that cross on top. And if we magnify that, and indeed this is magnifying the Lord, isn't it? Here are the little hooks. Now, this is so wonderful, I probably shouldn't even be telling you this. This is just too wonderful to even think about. These little hooks have a radius of curvature right here that precisely matches the curvature of the lip that it has to hook onto. Now, that's a great idea, right? You really don't want a big hook on your screen door and a little eye. Nor do you really want a big eye and a little hook. The hook and the eye have to fit. And indeed they do. Now you notice this hook is not in the right position to hook onto the groove over here, so there needs to be a hinge down there. And oh my, what a lovely hinge we have. There are just millions of these on a single bird. Millions and millions. And it's like Velcro. They swing over from their hinge and they grab a hold of that little lip there and they lock the whole feather together. That's why you can take a feather and kind of ruffle it up, and if you kind of groom it between your fingers, it all latches back together again. And birds do this just by running their beak through the feathers, and these millions and millions and millions of little hooks on their feathers just all lock automatically. You know what the evolutionist says this came from? This is a frayed scale from a reptile. As the birds evolved, the reptile scale got frayed and eventually produced a feather like this. Well, that's really a pretty ludicrous idea because a scale and a feather have no relationship at all. They come from completely different structures in the body. If we magnify that a little more and also tip the feather over so the hooks are going down, There you really see what the Lord has done here. This is the hinge right here. Can you see this little flat area? It's like a strap hinge. Now to see it's broad, you're viewing it edge on here, and that allows that hook to move just in one dimension. It doesn't go left or right, it just moves like this. And when the hook comes down, there's a little probe that guides it in. And then there's a little strut up here. You see these grain elevators where they have the tubes that take the grain up to the top of the grain elevator? And that tube could bend, couldn't it, under the weight of the grain? And there'll be little struts that stick out and cables that go out and in, and it strengthens the tube. See the same thing on a sailboat. You have one of those little jumper struts right here to strengthen this structure. And this whole thing is coated with a double interference layer like an oil slick so that it can refract light back and produce the iridescent colors that you see in birds like grackles and the green head of a mallard. There's so many wonderful things here. I do a whole lecture just on feathers. But I just brought this up to show you that indeed you could be fooled into thinking there's intelligent design in nature, couldn't you? I mean, if a person didn't know any better, you could come to that conclusion. But you know, the evolutionists say, forget about it. Don't tell us how complicated it is. This big brouhaha we had in Kansas here back in 1999 where they wanted to change the state assessment exam, and the evolutionists just went crazy. And one evolutionist from Kansas State University said he didn't care what kind of design you showed him. He says, even if all the data point to an intelligent designer, such a hypothesis is excluded from science because it's not naturalistic. In other words, don't show them how complicated things are. They, frankly, don't care. Why don't they care? Because up front, a priori, up front, they've decided that the whole of nature and the whole of existence must be pure naturalism. There must not be any God. There must not be anything outside of nature. Nature must self-assemble in and of itself. And it's that bias that causes them to make statements like this. Don't confuse me with all this complexity. I don't care if all the data point to an intelligent designer. We're still not going to believe it. Now, is that necessary? Does science have to take this approach? No. Dr. Richard Lowenton, who's a professor at Harvard University, in the New York Review back in 1997, talked about this naturalistic bias that many people in science have, and certainly evolutionists have. And he said, it's not that the methods and the institutions of science somehow compel us to accept a material explanation of the phenomenal world, but on the contrary, we are faced by our a priori, that means up front, before we do anything else, a priori assumption to adhere to material causes to create an apparatus of investigation and a set of concepts that produce material explanations, no matter how counterintuitive, no matter how mystifying to the uninitiated. Moreover, and this is critical, that materialism is absolute, for we cannot allow a divine foot in the door. Well, this is their starting assumption. I mean, this is where they're beginning. No wonder they don't see evidence for design in nature. Step one, they say there are no designers. Then they say, show me evidence for design in nature. Well, of course, that's not going to happen. Here's an interesting question. If we just turn from Scripture for a little bit and just look at nature apart from what we learn from God's Word, could we just look objectively and see evidence for design in nature? Or could we really be fooled? Well, I first of all looked up the word chance and design, since that seems to be the controversy here in the dictionary. Chance is the absence of any known reason why an event should turn out one way than another. Fortune, fate, luck are synonyms. The word design, on the other hand, means to plan and fashion artistically or skillfully, to intend for a definite purpose, to form or conceive in the mind, to contrive and to plan. A lot of synonyms here. What do they all have in common for design? Forethought. Knowing in advance which you wish to do and then set out to do it. That is fatal to evolution. Evolutionists will not tolerate forethought. Evolution has no forethought. It occurs purely by chance. Now, this particular slide here is interesting because it comes from this data comes from the movie Contact. I don't know if you've ever read the book or seen the movie, but Carl Sagan is looking for any evidence of intelligent design or life in outer space. Of course, he's an atheist here on Earth and doesn't believe that there is any purpose in creation or in biological systems, but they figure there may be intelligent life out in space, and in the movie they got this signal that was a series of beeps and pauses that were interpreted as ones and zeros. So they got 1 1 0 1 1 1 0 1 1 1 1 1 0 and so on, as you see here. And they ran this through a filter to look for any kind of a pattern or specification. And it turns out what they were getting from outer space, and of course this is just a fiction, nothing like this really happened, is they received basically the number 2, 3, 7, 11, 13, 17, 19, so on, up to 101. This turns out to be, what do they call this yet? These are, pardon? Prime numbers, right. Prime numbers from 2 to 101. And so right away, the person who got this signal and processed it through the computer come up with this statement in the movie. He says, "This isn't noise, this has structure." So prime numbers would not be the result of chance in their view. The probability is so extremely low that they can assume, in the movie for educational purposes, that intelligent beings in outer space were communicating with them. So this proves that even the scientific community and even atheists are prepared to recognize design when it's there. There's a gentleman by the name of Dembski, and he has come up with, he calls his explanatory filter. And in this filter, he says we can look at nature and tell whether we're seeing something designed or just due to chance. The first question he has whenever he looks at an object or phenomena is, does a law explain it? Is what we see just a law of nature? If it is, it will be repeatable. You'll be able to see it again and again and again. If I drop this, it falls to the floor. What is that? Well, that's a law of nature. Every time you drop it, it goes to the floor, and it'll do so even on another planet. So it could be a law. Another possibility is, does chance explain it? There we're really asking, is it statistically probable? If I flip a coin 10 times and I get 7 heads, could that be due to chance? I think you agree that it would, but if I flip the coin 100 times and I get 100 heads, you know somebody's cheating, right? Somebody's designing the outcome. So if it's due to chance, we're really asking, what are the statistics? Do they support chance or that there is design here? And if so, we ask the question, does design explain it? And if that's the case, is it specified? Does it achieve a particular objective? Well, did I tell you there was going to be an exam? There was no mention of this? Oh, it's too bad. Here's your exam. Here's a honeycomb. Somebody once sent a letter to Charles Darwin and said, "Charlie, what about the bee's honeycomb?" Why, every junction here, three-way junction, is a 120-degree co-equal angle. These are very precise hexagons. These hexagons represent the least amount of wax to house the maximum possible amount of honey. If you had little square boxes here instead of hexagonal, 6-sided boxes, it would take more wax to enclose the same amount of honey. There's nothing more efficient than just the hexagon. And Asa Gray had sent a letter to Darwin, says, "What do you think?" Darwin says, "Oh my, beyond this natural selection can't go. Why, this is phenomenal." But you know, if Darwin had just looked at soap bubbles in his bathtub or whatever, he would have noticed that soap bubbles pack in a hexagonal way just like the bee's honeycomb. You know, if you have a solitary wasp and they make one cell, it's a cylinder. But if you have a community insect like a bee and they make several cells at once, they pack together just like soap bubbles to make hexagons. So this would be a law of nature, the law of hexagonal close packing. Peaches in a box do this, peas in a jar do this, soap bubbles. Nobody has to go in and make these little hexagons appear. They just do that automatically. So that would be a law of nature, but you could be fooled into thinking that that was perhaps a special design. What about this? You find a stone, a couple of stones. Would you say chance or design for either one of those? Most people would say this probably chance, this design, but why is that so? Is it just because it's symmetrical? Is that all we're looking at? No, you see this fracture plane right here is following a natural cleavage plane in the rock. It's highly probable that that fracture would occur right there, if you look at the grain of the rock. Over here, this little niche here and the niche here really aren't following any special fracture planes. Somebody had to specify that. They wanted it there. There were a lot of places the crack could have run, but it was sort of forced to run in this pattern. So now let's just sort of sit back and look at a mountain here. You see a lot of grooves and creases in this mountain. Is this because somebody went up there and carved those little creases? No, we could show that weathering was a result here, just water freezing and cracking and breaking. And this again would follow the natural cleavage planes of the rock. The thing that was amazing, though, is 20 years later, somebody took a picture of the same mountain, and just due to random weathering and wind and what have you, you just wouldn't believe it. This is what they got. You know, I don't think you believe anything I'm telling you. We're going to get Ronald Reagan, I think, right up here next. I think Bill Clinton's down here someplace. I'm not sure. But anyway, all right, take that back. I'm not supposed to get into politics at all here. Sorry about that. That's terrible. Anyway, could you tell that this was carved intentionally? Let's say you came in from another planet. You not only didn't know what presidents were, you didn't know what people were. Could you still tell that this was carved intentionally? This was designed? Yes, you could. If you went up and took a real close look at things up here, you would see that these fracture planes that made the nose here in this particular part, these followed planes that were forced to occur. They were not following the most logical, the most likely natural planes of the rock. So we can objectively tell whether a rock has been carved or not. And that's how even evolutionists can look at a piece of rock and tell that it was a stone tool that was designed and built, and not just some piece of rock that happened to be chipped in the shape of a stone tool. Well, here's a really difficult question here. We have two fences, this picket fence up here, and there's another picket fence down here. Maybe one of your neighbors builds something like that, and your wife is always telling you, why don't you build a nice fence like that? And then you have this other neighbor. Don't you wonder about him? I mean, there are boards missing, there are long boards together, there's short boards. This is really a mess. Which of these two fences has the most order? Well, the top fence. Now, which of the two fences has the most complexity? Don't you hate trick questions? You see, this one has the complexity because you see your neighbor is trying to communicate with you. He has used specified complexity. Look what he's done here. He's used International Morse code. And in Morse code, did it means an I. And instead of using dits and das on the code key, he's just using boards. So this would be did it, da dit, da da da, did da dit, so on. If you know Morse code, you'd know that spells out the word information. Now, imagine if you're going to describe to somebody how to build these two fences. Up here, you would say, start with a stack of long and short boards, put up a short board, then put up a long board, and continue in this fashion until you run out of boards. That would be the whole instruction set for making this fence. But this fence down here, oh, this is interesting. First of all, what language did you have in mind? English, French, German, whatever. Depends on what your neighbor knows, right? And then the next thing you'd want to decide is what kind of a mechanism are you going to use to communicate the letters of this language. We've chosen English. We could have used binary code, but we chose International Morse code. The next thing you'd be concerned about is just exactly what information did you want to share, what words, what concepts, and does your neighbor understand these things? All of that enters in here because you see, we have just taken nothing but plain old boards, and with these boards, is it clear that we could spell out the whole Encyclopedia Britannica with boards? Now, does that give you a new level of respect for boards you've never had before? No, you see, boards are trivial. We could have used big stones and little stones, or we could have flashed lights like they do at the ships at sea. The boards are secondary. Where is the information? It's not intrinsic to the boards. It's simply being superimposed on the boards. And our body has information like that. And we have a code in our body. The code is called the genetic code. And where does this information come from? Where does the information, not where do the boards come, that's simple. Even the code is simple. The DNA itself is not the issue. Where does the information come from that is superimposed on the boards or the DNA? Let's look at a stack of books here. It's not important what these books are about. There's just some information in there. There could be a book of history and a book of philosophy here and maybe a book on how to improve your golf swing down here. Where did the information come from in these books? The evolutionist says we must look at the material and not look anywhere else. We just look at the material universe. We must not look at any intelligent source outside of the material. So let's try that. What do you think? Paper? Paper produces information. Given enough time, paper makes books. No, I think maybe the paper plus the ink. Given enough time, paper and ink makes books. I don't think anybody's too impressed with that either. Well, let's think more broadly. Matter. Matter itself, left to itself, writes books sooner or later. Let's think even broader yet. What about matter and energy? My goodness, that's kind of like everything, isn't it? If you're looking at the material universe, matter and energy, that's kind of like everything. Can we get books out of matter and energy? Nobody ever has. I think I'm onto it. Chance. Does chance do it? You know, we could try that. We could try writing a book with chance, but let's keep it simple. Let's just try to write this little phrase, the theory of evolution, in capital letters by chance. What would be the chance of writing that by chance? Well, that can be figured out. We could take a sack with Scrabble letters, you know. How many letters in the English alphabet? We have 26 letters, and we need space, so we use a little space block and then the 26 different letters. We shake up the bag. We reach in. What's the chance of getting the T? One chance in 27. That's 26 letters plus a space. And then let's say we just happen to get the T by dumb luck. It'd be one chance in 27, not too extraordinary. We would write that on a chalkboard and say, well, we got the T because we're going to use natural selection to look for the theory of evolution. So we managed to get a T. So now we put that letter back in the sack. You can't run out of letters, so you have to put it back and shake the bag again. We call that a Bernoulli trial. And what would be the chance of getting an H? Oh, 1 in 27 again, because you put the letter back. But what's the chance of getting the T and then the H in succession like this to put this together? Well, that can be figured out for the whole phrase by taking 1 in 27 times 1 in 27 times 1 in 27, 23 times for each of the letters and spaces in the phrase. So now we can say, what is the probability of spelling the theory of evolution, that phrase, by chance? And you would expect to succeed by chance once in 800 million trillion draws. Well, let's hustle right along. Let's do it quickly. Let's move at the speed of light. We will try 1 billion combinations a second. Hey, it isn't going to take too long at 1 billion combinations a second. I can tell you that. In fact, at 1 billion combinations a second, you succeed once every 26,000 trillion years. Do you get the idea? We're not going to put Einstein's brain together by chance. I don't think I'm going too fast, am I? No. You see, to the evolutionists, they say the whole of reality is matter, energy, time, and space. That's everything. We have to be able to get the information out of that, but we don't. It turns out information is just another whole separate thing, independent of matter, energy, time, and space. And where does the information come from? I believe it comes from a creator, no question about it. Now, we have that information in our body. It's called the genetic code. You've heard of genes and what have you. They're in the cells of the body. That's where the information comes from, as far as we know, to make our body and all of its parts. It's been said that the DNA, which is what that code really is in our body, contains the equivalence of about 1,000 books of information. Now, where do the 1,000 books of information come from? Who wrote all the books? When we look at the DNA, it's kind of wrapped up like a phone cord in a coil like this, and a little copy is made when it unravels in a certain place. This little copy comes out through a hole in the nucleus. Hey, if there wasn't a hole in the nucleus, it'd be the end of life. Good thing we got a hole here. So out comes this little message. It feeds through a really complicated machine that has about 70 different proteins in it. And thanks to a lot of other very complicated biochemistry, the amino acids that make the proteins of our body get put together in the proper sequence. That's what DNA is all about. To get the amino acids, here you can see their little blocks, hooked on in the right sequence. First this one, then this one, then this one, then this one. Or I should say it was this one first, then this one down the line. It keeps adding to the chain. Now, let's just look at a typical protein. All the enzymes of our body are proteins. Our muscle is protein. You know, practically everything you can think of, the building blocks of life, are proteins or sugars or fats. And the proteins are made up of little units called amino acids. And there are 20 different amino acids that are used in our body. And we could let those amino acids be represented by different color beads. To get 20 of them, we could call them A through T. So we have little letters on, which are simpler than their scientific names, which are complicated. So amino acid A, B, C, D, E, F, G through T with different colors, and that would be one sequence, right? Now you could put different sequences. You could take the T and put it over here between the D and the E. That would be a different sequence. We know that the average protein in our body contains 500 amino acids. That's average. And I actually went to the trouble to put 500 of these little dots in a row here, back and forth. This would represent the sequence of the little beads or the amino acids in one typical protein in your body, and you have 100,000 different proteins in your body that we know of. And the Human Genome Project came up with 30,000 genes. We've got 3 times as many proteins as we have genes to code for proteins. But there must be some way of getting more than one protein out of a gene, certainly. Well, what's the probability of putting then a particular protein together by chance? I mean, with 100,000 different proteins in our body, we have to come up with a lot of them, and if evolution worked, we'd have to come up with them by chance. One of the proteins in the body is hemoglobin. It makes blood red. This is a red blood cell, and it binds the oxygen, because you see, oxygen doesn't want to dissolve in your blood because the blood's warm. You drink warm water, it tastes flat. The reason it tastes flat is oxygen doesn't like to dissolve in warm water, and that's why it tastes flat. So how are we going to carry oxygen to our big toe from our lung if you can't get the oxygen to dissolve in the warm fluid? Well, hemoglobin has an affinity for oxygen, kind of latches onto the oxygen, and hemoglobin is made of 539 amino acids. It's a fairly typical protein. And what I've done is to say, let's assume we start out with all of the right proportions of all of the amino acids, and let's say this is the sequence, letting the amino acids be represented by A through T. This would be one combination, A through T, A through T, A through T over and over again until we've used up 539. Now, how many different ways could we put that sequence together? Oh, there's a lot of ways, man. Look at this. This is a big number. My friends, that number is larger than the American national debt. This is the number of ways you could put it together, of which only a few would work. The rest wouldn't work. Now, how big a number is this? Let's just tackle this thing. See the red 4 with the zeros? No clock has ever ticked that many times. Clocks have never been around that long. That'd be 40 billion. In fact, no clock has ever ticked 1 billion times. Every time we add a 0, the number gets 10 times larger. Let's look at this many zeros from here to here. It's been estimated that there could never have been more proteins than in the history of the whole universe. That doesn't make any difference how many inhabited planets you want to propose with life on them. Nobody is assuming you could have more proteins than this in the whole history of the universe, and yet this is a combination. This is your chance of one out of this to get any one particular protein. Well, let's look at this number. When you get to this big, you might as well just forget about any bigger number, because this number exceeds the number of atoms in the total known universe. And we haven't even begun to appreciate how big this number is. All we know is that this much, the red zeros, represents, by current estimates, the maximum number of atoms in the universe. Now, can evolution produce information through natural selection? Can it somehow select and create this information? That's what the evolutionists tell us. We call this microevolution, where little changes occur in organisms. These moths here are peppered moths. They're like people. They come in all shades from white to black. Lord doesn't like to bore us, so he gives a little bit of variability. And you can see why they call it the peppered moth. It's kind of peppered on the wings. And some years ago in England, somebody noticed that, well, there were getting to be more of the white peppered moths, or there were more white peppered moths because the birds could see the black ones, he assumed, and they couldn't see the white ones, and so they mainly ate the black ones, and that's why you had so many white ones. Then there was an industrial revolution in England. This was several years ago, and the trees got darker because these lichens that live on the surface of the trees died off. Now you can hardly see the black peppered moths, but you can see the white peppered moths. And the birds then ate more white ones than black ones, according to this study, and now you get relatively more black ones. And we were told that if you can believe that, you certainly can believe that man has evolved from an expanding cloud of hydrogen gas. Now, I never had any trouble with this. You notice they don't turn green. Did you notice that when they're on the green tree? They're still peppered moths, right? Whether you have the black ones or the white ones, they're still peppered moths. But it turns out this isn't even true. It's a hoax. These peppered moths are glued and pinned to the trees. They don't live on the tree trunks anyway. People went out and tried to reproduce Kettlewell's experiments. They said, we don't see any of these things, well, once in a while on a tree, but they live up under the leaves. So the color of the trunk doesn't mean anything. Plus, they are only running around at night. Kettlewell did his experiments during the day. He didn't like going out at night. So he would turn the moths loose, and boy, they're blinking at the sun. They were landing on his legs and everything else. It had nothing to do with their natural behavior. But anyway, even if this were true, this isn't evolution because you still have peppered moths when you get to the end, don't you? Let's look at how natural selection works. First of all, consider two dogs. We have a double set of genes in our body. We get one set of genes from our father and one set from our mother. So we all have double sets. And sometimes these genes that we get from father and mother can be almost identical. And sometimes one can be a little different than the other. We call these alleles. Different versions of normal human genes. They just come in different versions. And that's why we all look a little different, because we have these alleles. Now consider two medium hair dogs with medium length. And let's say they have this medium length hair because this animal has long hair genes, and we have this illustrative long hair coming off that chromosome. That's cheating, but you get the idea. And over here, this one came from the other parent, and that's for short hair. And if you combine the long hair allele with the short hair allele, you get medium hair, right? And if a short hair, long hair allele in a female and a short hair, long hair allele in the male, if these two breed, what kind of pups can we get? Well, if you get the two short hairs together to produce this dog, you get a short hair dog, right? Makes sense? And then you have two different ways of getting medium hair. You can get the short hair allele and the long from the female, or it could be vice versa. So there's two ways. You get twice as many of these medium hair dogs. And then by taking the long hair allele from both, you get what I think is just one handsome dog. This is I love this dog. Now, how does natural selection work? Natural selection would work in the following way. Let's assume that it gets really, really cold. So cold that dogs that don't have long hair die. That would be nature selecting. So this is pretty sad. You might not even want to look at this, but these three dogs die off. Short hair, medium. All we have left is the long hair. And he runs around, and he's very fortunate. He finds another long hair. After all, that's the only kind that survived this weather, right? And these two get together, and they have pups. The question is, what kind of pups can they have? This is natural selection. We've selected these short hair out, and we've selected for the long hair. The kind of pups you can get are the long hair the long hair, the long hair, and the long hair. Do you realize what's happened here? We have lost genetic information. We haven't come up with something new. We have lost some of the information we had. So natural selection can't produce something new. It can only reduce the information of what you already have. For example, dogs probably all come from a wild-type dog that looks pretty much like a wolf. And from a wolf, you can get other types of dogs like coyotes and dingoes and collies. And finally, way, way, way down here, you can get a poodle. Now, did we come up with new genetic information to put the poodle? No, actually the poodle has less information. We have selected from the wolf only certain traits until we get finally this poodle. No new information is added, rather information is taken away. So while you could get a poodle ultimately from a wolf-like dog, there's no way you can start with a poodle and breed back to a wolf. You've given away some of the information along the way. That's why some years ago, evolutionists meeting at a conference at the University of Chicago, we're talking about microevolution, which is how you get these variations among the individuals of a single species. And it said the central question at the Chicago conference was whether the mechanism of microevolution, that is the variability among species and natural selection, could be extrapolated to explain the phenomenon of macroevolution, which is how you get, presumably, humans from ape-like creatures or birds from reptiles. And they said the answer can be given as a clear no. There's no way we can extrapolate that. You see, the only way you can get something new, something we call macroevolution, is through mutations. Now, mutations really do occur, sadly. Here are some mutations in our human body. These are human cancer cells. They come from a cervical carcinoma, and this is due to mutations that occur in the cells. Now, the thing that's amazing is as you sit here this evening, the lights and what have you are causing mutations in your body right now. We're getting mutations that are initiated in our body by the dozens every day. But we can thank the Lord that there is a mechanism that repairs these mutations, actually snips them out of the DNA, makes a corrected patch, and splices it in. It's called excision repair. As far as we know, it occurs in every living thing from bacteria to man. Life would be impossible without it, at least since the fall into sin, when mutations started to develop in earnest. And so we survive because of this repair mechanism. Now, this repair mechanism involves at least 12 different enzymes to make it work, and these enzymes are proteins. Here's a frightening thought. What if you had a mutation of the mutation repair system? That would get serious, wouldn't it? A mutation of one of those enzymes, those 12, in the repair system. Sadly, this occurs. And the next picture is not pretty. But it shows you what your life would be like if you didn't have mutations being repaired at all times in your body. This particular disorder is called xeroderma pigmentosa. It is fatal before reproductive age. There, but for the grace of God, we'd all be were it not for the fact that mutations are being repaired. Do you see the problem evolutionists have? Mutations will kill you. You wouldn't even be alive if most of them weren't repaired. But if they were all repaired, that'd be pretty much the end of evolution, wouldn't it? So the evolutionists say, isn't it wonderful we have just enough mutations so that everything can evolve and not kill us? Well, here's a question. Are there any good mutations? I get asked this all the time. Are there good mutations? Well, if you look at it from the point of view of the organism, there are certainly mutations that seem to benefit the organism in some ways. But are they the result of new genetic information? Nope. Once again, no new information. Let's look at how it works. You've probably heard people tell you that the fact that bacteria can become resistant to drugs proves that organisms can evolve through mutations and get improvements. This bacterium is Helicobacter pylori. It's a bacterium that causes stomach ulcers in people after about the age of 50. And we have an antibiotic to kill this bacterium. And the way this antibiotic works is it soaks through the surface of the bacterium, and once it gets inside, it combines with a naturally produced enzyme in the bacterium that the bacterium uses for some other purpose we won't get into. And when this antibiotic comes in, it combines with this natural enzyme produced in the bacterium, and the antibiotic plus enzyme makes a poison. And the poison kills the bacteria. Now, eventually you may find you're not killing the bacteria. Evolutionists say, oh, see, there you go, we're evolving. Well, let's look at what happens. In the mutation, the normally produced enzyme inside the bacterium, which has some other function for the bacterium, is no longer being produced. And when you no longer make this normal protein, this enzyme, now when the antibiotic comes inside, it has nothing to combine with to produce this poison. And so the bacterium survives. I don't really mind the survival so much as it laughing at us. I really hate that. Now, is this evolution? No, because look, it survived because it has less information, not more, less. You lost a whole enzyme that's normally produced. You see, Lee Spetner, who's written a wonderful book called Not by Chance, and we have it available out there if you're interested in buying it. It's kind of pretty serious biology, so if you have a background in biology, you'll love this book. But he's a very distinguished molecular biologist, and he said, not even one mutation has been observed that adds a little information to our genome. Nobody's ever seen a mutation produce new genetic information that serves a particular purpose. In fact, remember Richard Dawkins? We talked about him before. He's the atheist that said, it looks like there's design in nature, but there isn't. He was asked recently in an interview whether he could come up with any examples of this. Let's listen to this. Hopefully the sound will work for us.
Professor Dawkins, can
you turn it up?
Of a genetic mutation or an evolutionary process can be seen to increase the information in the genome?
This is his answer. Now, if you're an evolutionist, this is just the minimum. If somebody asks you, after all, the whole of living things all happen by mutations, right, in evolution. And if you're asked to give one example out of the whole of nature of a case where mutations produce new information, and you can't come up with anything, that means you have an idea that really isn't based on much of any real facts. What are the conclusions that we can come to from all of this? We've seen that there's just simply no way you can deny that the complexity of the human body is a result of intelligent design and purpose. And in Romans chapter 1, verse 18 to 19 in the Scriptures, the Lord tells us that the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men, who suppress the truth in unrighteousness, because what may be known of God is manifest in them, for God is showing it to them. Think of what this is saying. It says that man already knows there's a creator. The person that disagrees with you knows there's a creator just as well as you do, at some level. But they deny what they already know. They suppress the truth. Wow, that's pretty hard to change somebody's mind if they already know the truth, but they're suppressing it. I think we all do this at times. There are things that are so frightening, we don't want to think about it. And people don't want to think about a creator because it raises a whole issue of accountability. And so even though they know the evidence is there, they suppress this information. And it goes on to say that the Lord has not only given us this evidence, but He's shown it to us. He's made it evident to us. It's sort of like written in our hearts, just like our natural sense of the law. And that's why Romans goes on to say that, for since the creation of the world, His invisible attributes are clearly seen, being understood by the things that are made, even His eternal power and Godhead, so that they're without excuse. When we look at the visible things that God has made, the Bible tells us we see some of the invisible attributes of God, His eternal power and His Godhead. And when we go before the judgment throne of God, there's no way we're going to get away with saying, we didn't notice any intelligent design. We didn't see the handiwork of a creator. The Bible says we'll be left without excuse. Well, if you're interested in information from us and you have a computer, you can get in touch with Answers in Genesis on the World Wide Web. You just have to enter into your web browser, Answers in Genesis, all is one word, capitalization is not important, just run it all together, .org. And you'll get more information than you'll know what to do with. A lot of my lectures are on there, articles I've written. I'm going to be writing a series of regular articles that will appear on there starting pretty soon. And there's a database. You can look up questions on almost any subject. There's a bookstore on the web and the whole works. We are working on a beautiful new museum that you can pick up literature out in the lobby telling you something about what we have in mind for this museum instead of going to the typical museum where you just see constant evolutionary interpretation of the beauties of nature. This one will give the honor to God who is the creator. We have a great magazine, and if I were to ask what would be my single best recommendation, subscribe to this magazine. It's kind of a combination of National Geographic and Ranger Rick. It's in color. It's written for the whole family, from children to adults. Comes out 4 times a year. There are no advertisements in it. It's just all content. And it just touches on so many interesting things that come up every quarter that deal with creation and the evidence for God's work in nature, evidence for the flood. There's a special children's page, and I think it's just one of the better tools that we can use, particularly in the family. Might want to get a subscription for your church. Sorry Ken Ham couldn't be here. He's just a marvelous speaker. It's a special privilege just to be able to occasionally share the stage with him. But we've recently come up with a whole new set of recordings that you can get on either videotape or on DVD. Either way, and it's 12 lectures by Ken that pretty much covers everything you're going to hear from Ken these days, and his lectures, beautifully illustrated. If you're interested in the lecture I'll give next on the human body, there's a wonderful book called Bones of Contention that covers the ape men and so-called ape men and the evolution of man from a creation point of view. The book Not by Chance, I quoted Dr. Spetner, that there were no mutations that produced new information. This is one of my very favorite books, but it's a little technical. It's for somebody who has a science background that you would like to really give something to think about, too. This would be a book to get. We have a CD that you can pick up in the lobby, $5 each, $2 for 10 or more. And this is a critique of that program that was on Nova, the Evolution series, just beautifully done. In addition to that, it includes a complete video from a frog to a prince, and this video, which would cost $20 by itself, includes this interview with Dawkins you just saw, except you really get to hear the sound there, and you get the fun of seeing him sit and try to think of a single example of a beneficial mutation. It also includes a complete book refuting evolution, over 3 hours of audio lectures. I think some of my lectures are on there. Altogether, a pretty good bargain at that price if you got a computer to put that CD-ROM in. It runs on an Apple or PC. This is one of my favorite books written by Jonathan Sephardi called Refuting Evolution, probably the single best book to give to a high school to college-age student who's being challenged by a lot of the evolutionary views. Ken is an Australian, what can I say, and he doesn't know what subtlety is all about. When he puts a title on the book, you don't have to guess. Really basic, simple, general book that gets into the spiritual implications of this whole issue. This book is our best seller. It's called The Answer Book. It has 20 of the most common questions we get as we go around speaking, and I think you'll find that a very useful book. If you're only going to have one book on the subject of creation and evolution, this is a good one. And hey, don't go to your local Christian bookstores to buy these books because, sadly, most Christian bookstores don't stock books dealing with creation at all. You can get about 2,000 issues and copies of Left Behind and books that are like Left Behind, but you can't find a book dealing with God's creative work other than the Bible itself. This book has recently changed its name. I don't like the new name. The old name was called Creation Evangelism. I think the new name is Why Won't They Listen? But it's how to use creation in sharing the Word of God with people. One Blood is a wonderful videotape book. You can get it in either form. Deals with the whole issue of there's only one race in this world, and that's the human race. We're all sons and daughters of Adam and Eve, and Jesus died for the human race, and it really deals with the whole issue of racism, and I think it represents the only way to ever really deal with this problem successfully, and that is through the Word of God itself. Well, that'll give you some books to look at. We have them in the lobby. Let's take a break.